we're going to start today with a little bit of mathemagic. So I want you to think of a positive, it doesn't say it, but let's make our number positive, 2-digit even number. So think of your number. Now double it. Multiply by 2. Add 48. If you need to pause, go ahead and pause to do your calculations. Divide your number by 4. Subtract 7. Double it again. Multiply by 2 one more time. Now finally, subtract your original number. Now if you've done all of these steps correctly, then you are now thinking of the number 10. It's magic. Well, not really. Let's go through and think about what each of these steps does. So we're thinking of a positive 2-digit even number. It could be any even number from 10 through 98. So I don't want to sit there and check every single one of those values. So we'll use a variable. So we'll let x be our original number. So here we have, in step 1, we have the number x. Now, in step 2, we double it, so we have 2x. In step 3, we add 48. In step 4, we divide by 4. So we divide this entire sum by 4. Now in step 5, we subtract 7. In step 6, we multiply this entire expression, so we use parentheses, by 2. And then in our last step, step 7, we subtract our original number, and there you go, it's 10. Right? I look at this and I immediately think, oh, that simplifies to 10. Anyone? No. It's not obvious why this equals 10, but we can simplify this expression, and we'll talk about that, the vocabulary, in just a moment, but we simplify this. So here's our expression. So there's lots of different ways we can simplify this. We can rewrite 7 as 28 over 4 to make this one fraction. We can distribute the 2 into the fraction and into the minus 7. Personally, I would rather make my numbers get smaller before I make them get bigger. So I will start by simplifying this fraction. So I will write that. So I have 2 times 2x divided by 4 is x over 2 plus 48 divided by 4 is 12 minus 7. And then outside of the parentheses, we copy the minus x. We can simplify what is inside our parentheses. So we can't simplify the x minus 2, but the 12 minus 7 becomes 5 minus x. So now when we distribute the 2, x minus 2 becomes x. 2 times 2 times x divided by 2 becomes x. 2 times 5 becomes 10. And then we subtract off our x, and we are left with 10. So it actually does not matter at all what value x we start with. X does not have to be even. X does not have to be a positive number. X does not have to be an integer. X could be negative pi. And as long as we follow the steps properly, we will always end up with 10. As long as we simplify this expression properly, we always end up with 10, no matter what x is. Now, I had you start with a positive number to make the calculations easier. I had you pick an integer also to keep the calculations easy. I had you pick an even integer because somewhere in there we would have x over 2. And I just wanted to make sure that when you had x divided by 2, you had an integer working your way through the problem. And I asked for a double-digit number so that we got interesting numbers instead of just starting with the number 2 or the number 4. I wanted you to start with something a little bigger, but not necessarily too big. Right? This would also work if we start with the number 1,537 or 1,532. Right? But doubling that and then adding 48 and then dividing by 4, right, without a calculator, which you were not allowed to use a calculator in class, right, that would just take too much time to calculate. So this is not really mathemagic, it's simply mathematics. So now we talked about simplifying a mathematical expression. So the question is, what is a mathematical expression? So an expression is simply when we combine numbers and or variables using our operations. Right? And what are our operations? That's addition, subtraction, multiplication, division, exponents. So here's an example of a mathematical expression. 3x squared minus x plus 7. So some terminology when we talk about expressions. So the variable is a placeholder for an unknown number. Oops. So in this example, x is our variable. We have a constant term. When we have a number, a value that can only have one specific value, value. So in this case, our constant term is 7, because 7 can only ever equal 7. We have a coefficient, When a constant is multiplied by a variable, we say the constant is the coefficient. So we have two coefficients in our expression. We have 3 and we have -1. So coefficient is a constant multiplied by a variable. And then finally, we have what is called a term. So this is when we have a coefficient multiplied by a variable raised to some power or a constant. So in this expression, there are 3 terms. We have 3x squared, minus x, and plus 7. These are our terms. So an expression is different from an equation because an expression does not have an equal sign. An equation has an equal sign. Now, something else to note is just because we have a variable does not necessarily mean that we have, or a letter does not necessarily mean that we have a variable. We're not going to go into how to use this, but the equation E equals mc squared. E stands for energy, M stands for mass, and both of those can change. But C stands for the speed of light, which generally speaking does not change. It is a constant. So we need to make sure that when we're using letters, we know whether the letter stands for a variable or a constant. So now we're going to simplify a few expressions. So our first expression is 3x times the quantity of x over 3 plus 3 over x plus 1 over 3x. So we distribute. So 3x times x over 3 becomes 3x squared over 3. 3x plus times 3 over x and then the last term, 3x times 1 over x. So the first term simplifies. The 3's cancel, and we are left with x squared. In the second term, the x's cancel, and we are left with 9. And in the last term, 3x divided by 3x is just 1. So this expression simplifies to x squared plus 9 plus 1. Oh, wait, we're not done. We can write that as x squared plus 10. Now we're done. Now we have a fraction with a sum divided by a sum. So this is not equal. Oops. This is not, I cannot break this up into 15z to the 5th over 12z cubed plus 15z to the 4th over 12z squared plus 15z cubed over 12z. This is not, ooh, I wrote an X in there. This is not the same expression. We cannot simplify or break this fraction up based on this addition in the denominator. So something to note, I typically will write my z's with a line through it because a lot of times I write them quick, and sometimes I'll write my 2's quick, and there's not really anything to differentiate the z from the 2, so unless I draw that line. That's my personal choice. I have seen students make mistakes, write 2z, and all of a sudden it becomes 22 or becomes z squared. So making sure that you clearly differentiate numbers from variables is a very important habit to develop. So I can't really simplify with the sum, but we can recognize that each term in the numerator has a 15z cubed, so we can factor that out. Each term in the denominator has 12z. Again, we can factor out the 12z in the denominator. So in the numerator, we factor out a 15z cubed, and we're left with z squared plus z plus 1 divided by, now we can factor out a 12z. And you see how my 2 and my z look very similar, except for the line through it. And when we factor out 12z, we're left with z squared plus z plus 1. The z squared plus z plus 1 is multiplied in the numerator and in the denominator, so those cancel. So we are left with, so we can cancel this. We're left with 15z cubed divided by 12z. Z cubed divided by z equals z squared. 15 divided by 12. Each of those numbers is divisible by 3. So we are left with 5/4 times z squared. Now, for our last expression, we have a big fraction with 2 small fractions. Now, I am not a fan of fractions. I tend to make mistakes when I work fast with fractions. So I'm going to work slowly and carefully. I have a big fraction with a fraction in my numerator and a fraction in my denominator. That's a lot of fractions to work with. So instead of applying some random method that I don't necessarily understand why I'm doing what I'm doing, I'm just doing what my teacher told me to do, I'm going to rewrite my big fraction, this fraction, as division. That's all a fraction is. So I can rewrite this as 3x over 4x minus 4. I'm going to copy the numerator and divide by the denominator, 9x squared over x minus 1. Now, since I am dividing by a fraction, I can multiply by the reciprocal. And we can start canceling. So we see that we have a 3 in the numerator and a 9 in the denominator. That cancels, so we're left with a 3 in the denominator. We have an x in the numerator and an x squared in the denominator. And then x minus 1 and 4x minus 4 look really similar. I can factor a 4 out of this denominator, and we have 4 times x minus 1. The x minus 1's cancel, and we are left with 1/12. So in our last example, we are going to expand and multiply out. Let me use black. 2x plus 3 times 5x plus 7. So when I wrote this on the board, everyone said FOIL. Well, what is FOIL and why does FOIL work? Right? It's another rule that's many people just memorize and they don't understand why it works. And so if I give you a bigger problem, you cannot solve it because you don't understand the method. So let's understand what the method is. What are we trying to accomplish? Well, I can distribute. I can distribute this 2x plus 3, multiply it by 5x, multiply it by 7. So we get 2x plus 3 times 5x plus 2x plus 3 times 7. Now we can distribute the 5x into the 2x and into the 3. And we can distribute the 7 into the 2x and into the 3. So we have 2x times 5x plus 3 times 5x plus 2x times 7 plus 3 times 7. Now, if we look at each of these terms, so I am going to rewrite my expression using colors. So we have 2x, we have 3, we have 5x, and we have 7. This is equal to so let's see, 2x is red. See, we have a 2x and a 2x. Let's see, 3 is blue. See, we have a 3 here and a 3 here. 5x is green. We have a 5x here and a 5x there. And the 7 is yellow. So now we can see that when we multiply the first terms, we get 2x times 5x. When we multiply the outside terms, we get 2x times 7. When we multiply the inside terms, we get 3 times 5x. And when we multiply the last terms, we get 3 times 7. So that is why FOIL works. So if we're given two binomials, these are called binomials because bicycle means 2. We have 2 terms. 2x plus 3, 2 terms. 5x plus 7, 2 terms. When we're multiplying two binomials, we can just multiply the first terms, the outside terms, the inside terms, and the last terms. I don't particularly care right now what this simplifies to. I just wanted to demonstrate why FOIL works. So now we're briefly going to talk about the binomial theorem. But before we talk about the binomial theorem, we need to talk about choosing. What does it mean to choose something out of a set, choose a certain number out of a group, and how do we figure that out? So here I have 10 shirts. I've got blue, green, I've got green, blue, and pink for my kids. I like purple. Orange is school colors. Black because it tends to go with orange. Red and yellow because I went to USC, so cardinal and gold are USC's colors, and then gray and white to give us 10 shirts. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 shirts. Now, I'm going on an overnight trip with my family. I need to pack a shirt. How many choices do I have? If I'm packing, let me make another copy of this. If I'm packing one shirt, then I have 10 choices. I could bring the green one or the blue one or the pink one or the purple one. It doesn't matter. I just pick one shirt. I have 10 choices. I pick one. Yep. Now, let's say it's a weekend trip and I want to pack 2 shirts. Well, now I could pick pink and purple. I could pick orange and red. I could pick blue and orange. I could pick red and orange. Oh, wait, I already picked orange and red. Huh. Hold on. Well, let's think about this. As I'm packing, I have to pick one shirt first. So my first choice and my second choice. Okay. I have 10 choices. There's 10 possibilities. So let's say I have packed my purple shirt because purple's my favorite color. And now I'm picking my second choice. Well, there are only 9 choices left. So I've already picked the purple. It's not available anymore. So I'm feeling like I have some I want to wear an oxy colored shirt, so I'll pack my orange one. So now I have 9 choices. But it doesn't matter if I pick the purple shirt and then the orange shirt, or if I pick the orange shirt and then the purple shirt. Once they're in my suitcase, I don't care what order I pick them, as long as they're both in my suitcase. So when I'm packing 2 shirts, I have 10 choices for my first shirt and 9 choices for my second shirt. But there were 2 different ways that I could pack those shirts, right? Orange then purple or purple then orange. So I need to make sure that once they're in the suitcase, I don't care about the order. So I need to divide by the number of ways I could have picked those specific shirts. So I will put these shirts away back in my drawer or hang them back up in my closet. So let's see if we can expand this to packing 3 shirts. Let's make another copy just in case I need my closet again. So let's say I want to pack 3 shirts. So my first choice, there's 10 choices. I can go and pick from any number, any one of my 10 shirts. Once I have packed my yellow shirt, now for my second choice, there's only 9 choices left. I can pick any of these. So I'm going to pack a blue shirt. I want one more shirt. I'm going to pack a gray shirt. I had 8 choices and I chose gray. So there's 10 times 9 times 8 ways to pack shirts in order, right? First I packed my yellow, then I packed my blue, then I packed my gray. But I don't care if I pack my yellow and then my blue and my gray, or if my gray and then my yellow and then my blue, or my gray and then my blue, then my yellow, or my blue and then the yellow and the gray. Right? There's different ways I can pack these shirts. So when I'm going to actually pack, once I've picked the 3 colors to actually pack them, there's different ways I can pack them. So I go and grab my first color shirt. I have 3 choices. So I pick the yellow. Whoops. Now I have to pack my second shirt. There are 2 choices. So let's say I pack the gray. Now I go back and pack my last shirt. There's only 1 choice left. So I will pack the blue shirt. So when we're choosing, so in this particular case, I had 10 items and I was choosing 3. When I'm choosing, when I'm picking with order, I'm choosing 3 items. The first item, there are 10 choices. The next item, there are 9 choices. And the last item, there are only 8 choices. Now, after I've chosen an order, I realize the order doesn't matter. So I want to divide by the number of ways I could have chosen those 3 shirts in any particular order. So as I'm choosing those 3 shirts, I have 3 choices for the first one, 2 choices for the second one, and 1 choice for the third one. So something to note. So the number 3 comes up twice as I'm writing out my choosing. It is the first number in my denominator. I multiply starting at 3 and multiply down to 1. It is also the number of numbers in the numerator and the denominator. Notice my numerator has 3 numbers, 10, 9, 8, and the denominator has 3 numbers, 3, 2, 1. And that is why I include the times 1, because I want to have 3 numbers in my denominator. And then the number 10 is the first number that you multiply in the numerator. So numerator starts with the number 10, and you multiply out the 3 numbers going backwards, 10, 9, 8. And then the denominator starts with the number 3, and you multiply back 3 numbers, 3, 2, 1. And that is how we choose. So some easy things to choose. So 10, choose 0. If I'm not going to pack any shirts, let's say I'm packing a dress or sweaters or not t-shirts, I'm choosing to pack stuff other than t-shirts. How many ways can I pack none of my t-shirts? Well, there's only one way to pack none of my t-shirts. Leave them all in the closet. Don't take anything. Let's say I'm going on a long trip and I need to pack all of my shirts. Well, there's only one way to pack them all. I pick every shirt and I pack it. So whatever number we have up here, if we choose 0 ways, there's always one way to choose 0. If we choose all of it, right, there's 10 items and I choose all 10, there's only one way to bring all of them. If I want to pack one item, one shirt, if there are 10 items, there are 10 ways to choose one item. Now, I'm going to choose one item. I'm going to choose black. So I can either choose one shirt to take with me, or I can choose 9 shirts to leave at home. If I'm not packing any of my shirts, I'm packing other clothes, I can either choose the number of ways to bring none with me, or choose the number of ways to leave 10 at home. So similarly, 10, choose 3. So if I'm bringing 3 shirts with me, I can either choose those 3 or to bring, or I can choose the 7 to leave at home. So a couple of key formulas when we're using the binomial theorem is if n is a positive integer and, hold on, if n and k, actually, so if we have n and k are positive integers with n greater than or equal to k, so there's n items. If I'm choosing none of them, or if I'm choosing all of them, there's only one way to do that. If there are n items and I am choosing one, or if I'm choosing all but one, there is exactly n ways to do that. I have n choices and I'm picking one. And then if I want to choose k items, I can either choose the k that I am taking with me, or I can choose the n minus k that stay at home. Those are the main ideas behind the binomial theorem.